Welcome to qnawire.
Hello friends, here it is given two circular plates each of mass 4 kg are rigidly connected by a rod AV of negligible mass and are suspended from the point A as shown in the figure. If impulse of F delta T is applied at point D along negative z axis, we have to calculate the velocity of the mass center and angular velocity. For part A, impulse is equal to momentum. So impulse momentum equation we have to apply. Impulse is given F delta T minus K cap mvx plus mvy plus mvz. So Vx is 0 by constraint relation, Vy is 0, constraint relation, and Vz is equal to F delta T upon M. Substitute the value. F is given mass is given 8, so it will be minus 0.3 meter per second. So velocity of center of mass can be written as 0 I cap plus 0 J cap minus 0.3 K cap meter per second. So this is the answer of part A. Now B part. To calculate the angular velocity, first we will measure its moment of inertia. Moment of inertia along x direction will be 2 into 1 by 4 mr square plus mv square. Mass of each is given 4 kg. Radius is 180 millimeter, and the distance between them is 0.15. So on solving it, Ix you will get 0.2448 kg meter square. Along y-axis, 2 into half mr square plus mr square. So it becomes 3 mr square. Substitute the value. Mass is 4, radius is 0.18. So moment of inertia about z-axis we will get 0.504 kg meter square. Along z-axis, 2 into 1 by 4 mr square. Now substitute the value. V square 0.15 square so it would be 0.504 kg meter square. Moment of inertia of xy plane mv into minus r plus m into minus v into r, that means minus 2 mbr, 0.216. Along xz axis. Now to calculate moment, about the moment of momentum is equal to angular momentum. About center of mass g is equal to, let us see here, substitute the value. On simplifying left hand side, we can write minus Bf delta I cap j cap is equal to Ix omega x minus Ix by omega by I cap minus Ix by plus I by omega by j cap plus Iz omega z k cap. Simplifying this equation, resolving the equation into its component, equating the coefficient of I cap, j cap and k cap, you may write Bf delta t to be Ix omega x. Now substitute the value. B is given 0.15, force is given F into delta t 2.4, Ix 0.2448, omega x minus 0.216 omega by, this will be the equation 1. J cap Rf delta t minus x by omega x. I have forget to write here omega x or we can write it by corrected form. Substitute the value. R is given minus 0.18, F delta t is 2.4, summation x by is minus 0.216 omega x, 0.388 omega y. This is your second equation. Equating the coefficient k to 0 is equal to Iz omega z. So by these three equations we can find using equations 1, 2 and 3. Omega x we will get 0.962 radian per second. Omega y minus 0.577 radian per second, and omega z is 0. So angular velocity of the assembly can be written as minus 0.962 I cap plus minus 0.577 j cap plus 0 k cap radian per second. So this is the answer of B part of this problem. Thanks for watching it.